And I'm going to look at number 49. So this is an arithmetic. I want to find when n equals 64, find the sum of, or excuse me, sum of 68 of them. And how many do we have to add together to get 1661? Find the sum of the first amount of terms. And again, it has to tell you that's going to be arithmetic, or I'll tell you that's going to be geometric in order to set these things up. Yeah. So we know that's an arithmetic sequence, and we're going to have to find the sum with the series. So the first thing we're going to do is write out the rule for the nth term. Arithmetic sequence nth term rule, we start out with it's a sub n is your first term plus your n minus 1 times your common difference. What's your common difference? 7. What's your first term? 2. So your nth rule is going to be 2 plus n minus 1 times 7. So I get 7n minus 5 as my rule. Bless you. Thanks. Everybody okay with that? I want to find the sum of the first 68 of them. So the sum of 68 of them is going to be the first term. No, sorry, I forgot the rule here. Number of them. First term plus the a sub n all over 2. Let's mix it up my rules. So I want to find 68 of them. I know the first term was 2. And now I'm going to figure out what the 68th term is. A couple ways you can go about doing this. You can just substitute in 68 into your nth rule and throw it in the numerator if you want, or find it separately and write it down. It doesn't make a big deal, it works the same. So whatever this is. You guys get 16,082? Nope. Sweet, I got it right. Let's do that. You're alert. Messing with you. And then find the sum that winds up equaling 1661. So you do the same exact thing. How many of them are going to add together to equal 1661? So we don't know what n is. We know our first term was 2. We knew our rule is this. It's over 2. So now we know that we get 1661 is n times 7n minus 3 all over 2. What do I do next? Multiply by 2, very good. Multiply by 2 to get rid of the fraction. So we get a 2, 2, 3, and a 3. Right?
Yes.
And again, I don't know about you, but I'm sure not going to factor this because that just takes too long. What am I going to use?
I squared.
Y equals.
Yeah, y equals.
You were almost there. You were halfway there. Get squared, take half root of it. They don't get any funnier. I'm just going to go ahead and say it. Shut up. Do students in Taiwan disrespect their teachers? No? Okay. Sorry, let me put you on the spot. I harass these guys, so they're used to it. And then just look for your table. Whoa, there's a lot of.
You want a 0?
Yep.
22.
Oh, there it goes. There it went.
Why?
Oh! 22. Yeah, exactly.
It's really nice.
Yes, because if you look at the quadratic, you have two negatives, so one to be a positive 0, the other will be a negative 0. So you're only going to look for the positive.
So we get some practice.
We get a package. Sometimes you give us a package.
Yeah, I know. It's so slow.
I like packages.
Yeah, packages are cool.
Easier if I got all the problems right in front of me.
Yeah, it's like you can do this and then this instead of having to search your book.
Let's see. Did you guys do this one? Or this or not? Here, try this one. I don't think I assigned number 61, did I?
Which section?
Oh, you know what? Let's do 63, because I know I didn't do that one. And 11 3.
Yeah, you did the 63.
Yeah. Let's do 63, but instead of the negative 66 and 2/3. Yeah, right?
That's not fun at all.
That was like a test question.
-2. 200 over 3.
Oh, that's.
So this is geometric. So same idea, find the sum of 16 of them, and find the number of them you have to add together to get negative 200 over 3. Take a minute, do that one on your own, and we'll go through it.
Shut up.
So we find the sum of 16 of them. Well, we use our formula. Sum of that is first term, 1 minus.
So that's where I tweak. You're on formula.
Let's see.
It's geometric.
Yeah. Is it?
Oh.
It's a series.
Right?
The series have.
Oh, but it's telling you you're finding this. I see what you're saying about the dot, dot, dot. When in a case like this, it's going to say, hey, this series does go on, but it's what's the sum of 16 of them? How many do you have to add together to get that?
So you should have used the geo sequence, right?
The
Series.
The series has the pluses.
Right. Okay.
Why did I
So
use
here,
sequence?
what is your rate?
Negative 1/3.
Rate's negative 1/3. First term is negative 90.
Just forget everything.
So we have negative 90. 1 minus our rate, which is negative 1/3, to the end, over 1 minus our rate of negative 1/3. So when you type this in, oh, we got to go to 16, excuse me. That's where you have to be cautious when you put in all your parentheses. Alpha y equals to get your fraction bars.
bottom? Uh-oh.
It's a really long term.
Negative 90.
Now, I noticed that I forgot to put in the times negative 90, so I'll just press enter and then multiply it by negative 90 here in a second. Negative 67 and a half.
Yes. I came up with fractions.
Parentheses huge.
Wait, yep.
I came up with a fraction.
Now, how do you identify which one you're gonna use, like which?
All
The instructions, I cut the instructions off. If you read the instructions, it'll say, for part A, find the sum of the first n terms of the geometric series. For part B, find n for the given sum. So it's going to tell you geometric series, geometric or arithmetic series.
So it'll tell me if it's a sequence or a series, or do I have to figure that out?
When you do stuff like this with the pluses, it's going to be all series.
Okay.
So you know you have to use your series formulas.
So like when I'm trying to find just n, I would use the geometric series. When I'm trying to find
Well, the difference between one like this versus write the rule for the nth term in the geometric sequence, then find the sixth term. So here you're writing the rule, and write out the rule, and then you substitute in 6 for n. Or here's the rate, here's the first term, what's the rule? Here's the second term, here's the fifth term, what's the rule? And it has to tell you that it's geometric, or it'll have to tell you that it's arithmetic to know whether or not which one you're using. Because remember, when we did them like that, you were doing a system of equations, one of which you use elimination, the other one you use substitution. Geometric, you use substitution. Arithmetic, you use elimination.
okay. But like for B on this problem,
Yeah.
would you use the same?
Yeah, series.
Okay, geometric series.
Yeah, I just had got that part.
All right.
So then, this gives you, what was it, negative 67 and a half?
Yeah.
Find the sum of them that adds up to equal negative 200 over 3. Well, same deal. Sum of them, which was our first term, negative 90. 1 minus our rate, which was negative 1/3 to the n, over 1 minus negative 1/3. Excuse me. Negative 200 over 3 is negative 90 times all this junk, 1 minus negative 1/3 to the n over, be okay by saying 4/3?
Yeah.
Okay. So there's a bunch of weirdness going on the right-hand side. What I might do to make my life a little bit easier right away is take negative 90 divided by parentheses 4/3, and it should simplify that out. That way I can bring that to the other side. Okay. Just by putting that in, I'm simplifying the numerical portion, numerator denominator. 67 and a half. It's kind of funny. So then I can take parentheses, negative 200 over 3, divided by my answer, 67 and a half. And that'll give me some other crummy stuff. Okay? So I have this crummy stuff equal to 1 minus my rate to the nth power. Be okay with that? Yes.
Why didn't you just like multiply 4/3?
To what?
200.
I can do that too. I'm doing the same thing. I just saw all those numbers on one side and then brought them over. So then I'm going to have negative 1/3 to the nth power is going to equal 1 minus all that. What's that?
It's 9 feet,
It's awesome. I didn't notice that.
so it's that like the 9 is
You're no fun. Now, here's the problem. I'm writing the jump because it's 9, 8, 7, 6, 5, 4, 3, 2, 1 side. I can't log base with a negative, can I? It's not false. What does my exponent have to be in order for it to make it work from a negative to give me a positive solution? Is my exponent going to be even or odd? It's going to be even. It has to be even. What's that? Because if I have a negative value to an even power, it's going to be a positive value. So in order for us to be able to do this, I know that if I just eliminate that for right now, I know I have to get an even exponent to make it work. So if we log base all this junk, it should work. So if I take 1 minus my answer, hey, no, look what that is now.
There's no 8.
Because 7, 8, 9. Oh, wait.
That means there'd be no
Darn it, that would have been better.
7.
Also, they rock so far away.
So if I log base this with a 1/3, the alpha window 5s. God. With a fractional log base. This is great stuff. Who is right? No whammies. 4.
I hate when it's just such a simple answer. Like, I could guess.
Yes, ma'am.
Why are you just able to take negative off of all
Because obviously when we take a log base, the log base has to be positive value. Remember, the base was always greater than 0. Knowing that we have some value raised to an exponent that is giving me a positive solution, the base itself, since it was negative, the exponent has to be an even value. Because if it was an odd value, it wouldn't work. But if it's even, I can do that. So I was playing around with the actual numbers there, knowing the little meandering that you can do to make it work. Because you couldn't take a log base of negative 1/3, but yet I can do it the other way. It's a nice little subtle trick. You don't see very often, but it does work. So yeah, that's really nasty to get the answer of 4. And now you go back and look at the original problem. What's negative 90 plus 30?
4.
Negative 60. What's negative 60 minus 10? Negative 70. What's negative 70 plus 3 1/3? 66 and 2/3. 4.
4.
That's dumb.
It's dumb.
That's dumb.
It's a great problem.
That's dumb.
It's alphabetical.
Is it
Is that the order that you
SN is
Actually,
Alphabetical?
it's gotta be alphabetical. I don't know it. I'm just
I'm trying to think. Yeah, actually, you guys. I should probably.
Extra credit's gonna be like, it goes from biggest to largest.
4.
Yeah, small.
You gotta admit that's pretty clever though.
Yeah, but like,
It's not dumb.
no one would think, like, I feel like I could think of that, but then I'd be like, there's no way that's right. Just because there's gotta be some math problem to it.
I don't know.
Coincidence.
True. To be honest with you guys, go through the problems in 2 and 3 with your systems. Make sure you remember how to set them up. The last stuff we did in 11.4 is ridiculously simple. What's the only thing you have to worry about with R for infinite geometric series?
If
Yeah.
it's greater than
Absolute
one.
value has to be less than 1. It's the only thing you have to worry about. If it is greater than 1, it is no sum.
No sum?
No sum.
Ah,
So can we say no solution?
It can't be one either.
Correct.
Or is it no sum?
No.
No sum.
Because it has to be less than, the absolute value has to be less than 1. If it was greater than or equal
Look,
to.
Oh.
Yeah, if it's greater than or equal to, then it's no sum. I mean, we did all the stuff.
I said the absolute value is connected, it's obviously less than
That's why they look at the absolute value. Because remember, when you're dealing with geometric sequences, if you start graphing them, they look like exponential functions. So it's going to be, it can be exponential growth or it can be exponential division.
that. Like, it doesn't need to be absolute value. It's negative.
So you would just want to say it's between plus and minus 1.
And it would be like,
Are you considering?
Think of it this way: instead of writing that your rate has to be less than 1 but greater than -1, they're just saying
because then like negative 6 would work.
right. Well, it wouldn't work here either. But this is
Yeah, no, I-
this is just
I
it's
can
saving
do that.
ink. It's saving space in your textbook.
I know, I can understand why it's not.
Other stuff that I would look at if you want extra problems, I think we've done just about all of them. The chapter review's got some decent stuff. I know on the website I threw a couple of older, I threw some old review stuff on here, if you guys want to look at that. There are some review-ish things that I put in. Some of these problems talk about what's called recursive. We obviously didn't do anything with recursive. Recursive takes about 2.5 days to go through, and we don't have 2.5 days right now to get this stuff in. That's why we're not worried about it. So if you want to look at some extra problems that are right there on the website, by all means. I didn't feel that I needed to print that because you guys can just look at it and do a couple here or there. Evaluate the arithmetic series. Determine the number of n in the arithmetic series.
Okay, this will be a lot of
Evaluate the geometric series. Determine the number of terms in the geometric series. Evaluate the sums. Common ratios. Given 2 terms in geometric, that's the system of equations we'd solve for your rate, or you isolate the first term to start out with and go from there.
Wait, so in arithmetic you eliminate one, but
Yeah.
in geometric you just substitute in?
Correct.
Okay.
Given 2 terms, yeah, I wouldn't worry about, well, you can do 2 terms in the arithmetic sequence, you know how to do that, that's your system of equations. When it talks about what's called the explicit formula, that's, your, write the rule, your a sub n, that's all that means. And then the recursive one, it's different. We just call it explicit and recursive when we start talking about it, instead of just writing the rule for the nth term. And then at the very bottom, I have all the answers on here too, so. By all means, I didn't think that I needed to print out a 6-page review sheet for everybody when they can just kind of go online and look at it and work from there. Oakley dokley. We will do park review problems on Thursday. It's gonna be exciting. Wait till you guys see those. You're gonna love them. So much fun. Park questions are great.
If you get one wrong, you get the next.
No, that's only in humanities.